told that we're investing $4,000 at 7.25% interest for 12 and a half years, but the interest is compounded in different methods, and we want to figure out how much we're going to have at the end of that 12 and a half years. So the main equation that we're going to use to start with is A, which is our amount at the end, equal P, the principal we put in to start, 1 plus R, the rate that's in decimal, over N, where N is the number of times we compound in a year, raised to the N times T is the time in years. So for this first one, if we're compounding annually, the number of times we compound in a year is just 1. So the key here is N is going to equal 1. Alright, so A equals P, the amount we put in is 4,000. 1 plus, the rate in decimal is 0.0725. N, again, the number of times we compound in a year, which is just 1 for annual. And then N is in the exponent. Time in years, 12 and a half, so 12.5. And now it's just a matter of putting this into the calculator. Make sure you recognize that the exponent goes only with this 1 plus R over N portion. It does not affect the 4,000. So in particular, you cannot distribute 4,000 through. Also, make sure the multiplication of 1 times 12.5 happens in the exponent. Okay, so you could simplify some of these portions individually first. I'm going to demonstrate how to put this all into the calculator at once. So I have 4,000 times, so parentheses, 1 plus 0.0725 divided by, I'm going to go ahead and put the 1 in there, even though I know that that's just going to give me 0.0725. Raised to the, in the exponent, put parentheses, 1 times 12.5. And that gives me, when I round to 2 decimal places for money, $9,594.59. Okay, now what about the next one, part B? The only change is we are compounding quarterly. So quarterly would mean N equals 4. There's 4 quarters in a year. So the equation is going to be almost exactly the same. We still are putting in 4,000. Our interest rate is still 7.25%. 4 for now N, and that also happens up here in the exponent, and still 12 and a half years. Once again, all I need to do is put this into the calculator, but there is a feature which comes in very handy on the calculator at this time. If you do second and then enter, where above it says entry, the calculator pops up with what you just typed in, and you can now edit. And that's why I put the 1s in, because I knew this was coming. So I'm going to change that division by 1 to be a division by 4, and the multiplication by 1 in the exponent to also be a 4. And there I've got my new answer. So this is $9,820.08. Now look at the difference between these two amounts. We invested the same amount of money. We invested at the same interest rate. We invested for the same amount of time. But this one is, what, around $250 more, almost closer to $300 more than the previous. Why is that? It all has to do with the number of compoundings. The number of compoundings, you don't get 7.25% interest 4 times a year. You only get a fourth of that interest 4 times a year. But every time you get interest on your interest. So the difference in the dollar amount here is the interest we're getting on the previous interest. Well, if that's the case, then monthly should be even better. Monthly, N equals 12. So again, I use the same thing. 4,000, 1 plus 0.0725 divided by 12. The exponent, I need a 12 times 12 and a half. Okay, now, when I use the second entry feature on the calculator this time, it doesn't work out quite as handy because I need an extra space. is that just writes over it. So if I do 1, now if I put in my 2 for the 12, it's going to write over my parentheses. To get around that, you can go second, delete. Above it says INS for insert, and insert that other digit for the 12. And the same thing here, 1, and then insert the 2. Okay, and this time I get $9,873.14. Now again, it's more. It's not as significant as going from annual to quarterly, but it's still more money. Okay, now we got daily. That's got to be even better. So daily, don't worry about leap year. You can just assume 365 for the number of days. So A is 4,000 times 1 plus 0.0725 over N is now 365. And in the exponent, we got to multiply 365 by 12.5. So once again, when I do the second enter, and I go back and edit, I'm going to have to watch that I got to insert my next position. So 365 and 365. This one comes out to be $9,899.20. Again, not much of a difference compared to our first original one, but it's still more money. Ooh, what about hourly? So there we have to do a little bit of arithmetic. There's 365 days in a year, and there are 24 hours in a day. So my N is 8,760. So, A equal 4,001 plus 0.0725 over 8,760 for N. And in the exponent, I need to multiply 8,760 by 12.5. Okay, so second enter. Okay, now I already typed that in, but if I hit second enter again, it takes me back to a previous one. So it keeps on backtracking until, I don't know, there's probably 4 or 5 it'll go through. 876, insert the 0. And 876, insert the 0. Okay, looks like I got that all typed in right. And this one comes out to be $9,900 and round to 6 cents. Not a whole lot of difference from here to here. It's less than $1, but it is still more money. And I think you can even see, now if we did compounding every second, every half second, every nanosecond, we're going to get more money each time. Well, what about this one? F is compounded continuously. That means at every single possible instance in time, you get interest. So more than every half second, more than every nanosecond, every single possible instance in time. Now, if we were going to try to use this same formula, the number of compoundings would be infinite. We can't plug infinity into the formula. So here's where a new formula comes about, and it comes from something with calculus by taking a limit. But the new formula is A equal PE to the RT, often memorized as PERT. This is for continuously compounded interest. So we're still looking for A. P is still 4,000. E to the R, that's the rate now in the exponent, 0.0725, multiplied by the time. And I'm still going to have to be careful to make sure that this multiplication occurs in the exponent. Alright, so to punch this one in, new formula, so I can't use my second enter anymore. 4,000 e to a power, second, and then ln. That already gives me parentheses, so 0.0725 times 12.5. Into my parentheses, this is about $9,900, and 0.095 would round to 10 cents. So again, not much of a difference here. I only get 4 cents more, but hey, 4 cents is still 4 cents. But those are the two formulas that we have. Make sure you have them memorized and notice the differences. Here it's an N times T in the exponent. Here it's an R times T in the exponent.